In the previous video, we have seen that a big problem should be decomposed into a smaller subproblems. But after decomposing a big problem into the smaller subproblem, how to code for that subproblem? Here comes the concept of algorithm. Hello everyone, I am Gyan and you are learning Computer Science with Python for class 11th. In this video, we are going to learn about designing algorithms. Designing algorithms. What is an algorithm? The first question is, what is an algorithm? An algorithm is a set of rules. The set of rules that defines how a particular problem can be solved. That defines how a particular problem can be solved. So an algorithm is a set of rules that defines how a particular problem can be solved. And that problem should be solved in finite number of steps. Okay, so the problem should be solved and should be solved in finite number of steps. In finite number of steps is known as algorithm. So algorithm is the set of rules that defines how a particular problem can be solved in finite number of steps. That means the algorithm should not take forever to solve a problem. There must be finite number of steps in which the algorithm solve a problem. Each step of algorithm may require one or more operations. There are certain constants. Constant means a set of rules, a set of boundaries. So there are certain constants to be placed on the type of operations. The first constant on the operations is each operation must be definite. Each operation must be definite. The meaning of this statement is there should not be an operation like 6 divided by 0. This operation is meaningless. There should not be an operation like adding a number to alphabet. Operations used in each step should be meaningful, okay, and should be definite. The second constant applied on operations of each step of algorithm is each operation must be effective. Each operation must be effective. That means each step of the operation must be such that it can be done using pencil and paper in finite amount of time. Means you can solve that operation by using your pencil and paper in the finite amount of time. So such operations are called effective operations. And the third one is each operation must be finite. Each operation must be finite. That means an operation should not take forever to execute. The operation must be finite, must take a finite amount of time to execute. Okay, so what the algorithm is? Tell me. Algorithm is the set of rules that define how a particular problem can be solved in the finite number of steps. Means number of steps in which you are going to solve a problem should be finite. It should not take forever. Means it should not take infinite number of steps to solve the problem. And then you have various operations in each steps. And if I talk about one operation in one step, then operation must be definite. Okay, operation should be meaningful. It should not be divided by 0 like that. The operation must be effective. Okay, that means such operation can be done by using your pencil and paper. Then the operation must be finite. Any operation in any step should not take forever to execute. All the operations in every step should be finite. Means number of steps should be finite and type of operation in every step should be definite, effective and finite. Then such set of rules is called algorithm. So hopefully now you got the proper formal definition of algorithm. Now the question is, What are the components of an algorithm? Components of an algorithm. So algorithm have following three components. The first one is called input. Second one is called processing. And the third one is called output. These are the three different components of an algorithm. Inputs is the input given to the algorithm. Okay. This is the processing unit. You apply input to the processing unit to get output. Okay. And everything together is called algorithm. So you give input to the algorithm, then the algorithm process that input to create output. So input, processing and output are the three components of the algorithm. Now let's see characteristics of a good algorithm. Characteristics of a good algorithm. What are the characteristics of a good algorithm? The first one is precision. That means steps of an algorithm should not be confusing. There should be precise number of steps doing precise things. There should not be any confusion regarding number of steps and what each step is doing. There should be precision in the algorithm. The second characteristic of a good algorithm is uniqueness. See, each step of an algorithm should uniquely contribute to overall algorithm. Okay? Each step of an algorithm should have a unique value. Suppose that you have to add two numbers and then you have to print. Then you decide the two numbers n1 is equal to 2, n2 is equal to 3. Then you do n3 is equal to n1 plus n2 and then you print the value of n3. So the value of n3 is 5. N1 is just like a container having 2. N2 is just like a container having 3. N3 is also just like a container having summation of N1 and N2, that is 5. And then you are printing the content of N3. This is what you are doing. Now look at here. This algorithm has 4 steps. In the step 1, you are deciding the value of N1. In the step 2, you are deciding the value of N2. In the step 3, you are adding the value of N1 and N2 to get the value of N3. And in the step 4, you are printing the value of N3. Now let's write the same algorithm here. N1 is equal to 2, N2 is equal to 3, N3 is equal to N1 plus N2. Then again write N3 is equal to N1 plus N2 and then print N3. This step does not add any value to the algorithm. It does not cause the error. But this step, the fourth step here, does not add any value to the algorithm because we already have calculated n3 is equal to n1 plus n2. We are doing it twice. So this step is actually not adding any unique value to this algorithm. That's how this algorithm is not a good algorithm. But this one is a good algorithm to add two numbers. So hopefully you are getting my points. Uniqueness means every step should uniquely contribute to the algorithm. The third feature, the third characteristic of a good algorithm is finiteness. Finiteness. The algorithm should be finite. Okay. It must not repeat the steps endlessly. Yes, you can repeat the steps by using the loops as we have seen in the earlier videos, but it should not repeat the steps endlessly for infinite time. Execution of steps should come to an end after a finite time. The fourth one is input. The algorithm may require a specific input to work upon. And the fifth one is output. Algorithms should produce perfect output according to the requirement. Okay, there should be good relationship between input and output according to the requirement. That means if you write an algorithm to add two numbers, then input should be two integers 2 and 3 and output should be 5. There should be a proper relationship between input and output. If we execute the algorithm by two inputs 2 and 3, it should not be 6. That's what you should take care of. For a given input, the algorithm should produce a perfect output according to the requirement. So these are the various characteristics of good algorithm. Now we know that what an algorithm is, but how to represent an algorithm? How to represent various steps of algorithm? So next topic we are going to study is representation of algorithm. Representation of algorithm. There are two ways to represent an algorithm. The first one is flowchart and the second one is pseudocode. Flowchart is the pictorial way to represent an algorithm. A flowchart is a pictorial representation of step-by-step solution to a problem. Solution of a problem. You know that step-by-step solution of a problem is called algorithm. So flowchart is the pictorial representation of algorithm. Or in the other word, you can say that a flowchart is a pictorial representation of step-by-step solution of a problem. And what is the pseudocode? Pseudocode is an informal language. Pseudocode is an informal language in which an algorithm can be described. Informal language means pseudocode cannot be executed by any programming language. Pseudocode is just English-like sentences written step by step as a solution to a problem. That means an algorithm whose steps are written using English-like sentences is called pseudocode. Okay, pseudocode means a false coding which cannot execute on any programming language. Statements of the pseudocode are just written in English-like sentence. So these are the two ways to represent an algorithm. Let's start with flowchart. Flowchart. Before we learn formally about flowchart, let's use flowchart to solve a problem. Then we will use that example to learn about the flowchart more formally. So we are going to solve a question here. The question is, draw a flowchart to print even numbers. Draw a flowchart to print even numbers from 2 to 50. Draw a flowchart to print even numbers from 2 to 50. A flowchart always starts with ellipse-like symbol. Here you define start. Okay, draw an ellipse-like symbol and write the start. That is how you start your flowchart. In the next statement, we have to assign a variable with 2. Maybe you are not getting my points right now, but just listen to me. In the next statement, you have to assign a variable with 2. Now you may ask what this variable is. The variable name is I. Okay, I is the variable. What is a variable? Okay, I'm asking what is a variable. The variable whose name is I is a container which contains 2. You have to check that if the value of I is less than 50 or not. I is less than equal to 50 or not. So whenever you have to test a condition like this, you should use this diamond kind of box. So here you are checking if I is less than equal to 50 or not. And of course we are checking in the diamond box. If this is true, that means if still I is less than 50, then you need to print I. Okay, means if I is less than 50, this statement is true, then you need to print I. Okay, see, printing I is the final output. This is not an operation. Assigning 2 in I is an operation. So whenever you have to define an operation, then you need to use this rectangle bracket. And when you have to show input or output of your program, then you need to use little bit skewed rectangle bracket. Okay, assigning 2 to I was an operation, but printing I is an output. That's why we have used little bit skewed rectangle here. You should must give arrow. While drawing the flowchart, you should must give arrow. After that, you should change I. I is equal to I plus 2, because after printing the value of 2, you should go to 4. That's why you need to do I is equal to I plus 2. And again you check if 4 is still less than 50 or not. If 4 is less than 50, then you again print 4. After printing the 4, you again increase the value of I to 6. Again check if 6 is less than 50 or not. You keep on doing it until your I is not greater than 50. And when your I is greater than 50, this box will result false. And when this box result false, you should stop the algorithm. Hopefully you are getting it. Okay, that how we have drawn a flowchart to print even numbers from 2 to 50. And a flowchart is pictorial representation of an algorithm. Now let's start formal study of the flowchart. As we know that flowchart is a pictorial representation of step-by-step solution of a problem. Okay, we use various symbols in flowchart. I'm not going to delete this problem from here. In this area, we will learn about flowchart. Next topic is symbols used in flowchart. What are the symbols used in flowchart? So I'm writing a symbol and then purpose. The ellipse symbol. This is for the purpose of to start and to stop. Start and stop. As you have seen here, we have started with an ellipse symbol and we have stopped with another ellipse symbol. The skewed rectangle. This one. For what purpose this is used? Tell me. This is used for input and output. The normal rectangle. This is used for processing. Diamond. Decision box. The arrows. Don't forget to give arrow. If you forget to give arrow, that means this is a mistake. I just have forgot to give arrow here. This was a mistake. Okay. You should always give arrow. Okay. Arrow means in which direction you have to flow. From start you have to go this box. From this box you have to go this box. If this condition is true, then you have to go this box. Then you have to go this box and come back to the same. If this condition is false, then you have to go at this box. So you always give the direction of flow. Such arrows are flow of control symbols. There are a few more symbols used here. This one is called annotation. The circle symbol, complete circle, is called connector. So these are the symbols used in flowchart. There are few more definitions which is valid for the flowchart, valid for the pseudocode, and also valid for the programming language like Python. So let's see few more definitions used in flowchart. The first definition is identifiers. Identifiers. In this flowchart, we have used a variable whose name is I. I already explained what the variable is. Okay. The variable is like a container whose name is I and which stores 2 in it. Okay. This is what the variable is. But who decides the name of this variable will be I? This is the programmer. This is you who have decided the name of variable as I. You could write here A, you could write here apple, anything you could write here. You could write here any word of English. You could write here any English alphabet. You could write here any English word. So whatever you write here, that will be name of the variable which contains the value 2. When a name is decided by programmer, when a name is decided by you, just like you have decided here at this point, so such names which are decided by you is called the identifier. Getting it? So identifiers are the names given to various components of a program by the programmer. Identifiers are the names given to various components of a program by the programmers. Example, names of variables, names of functions, modules, etc. You may not know about functions and modules right now, but inside a program, if as a programmer you decide a name, then such names are called identifiers. So the names of variables, functions, modules, etc. are called identifiers. The other definition we should know is called assignment. Assignment. When you write I is equal to 2, then you are assigning 2 into the container whose name is I. You are assigning the value 2 to the container whose name is I. You are assigning the value 2 to the variable I. Okay, this is called assignment. You always assign the value at right hand side to the variable at left hand side. Just see another example. I is equal to 2 and j is equal to I. This is also an assignment. The content of I, that is 2, will be assigned to the content of j. Okay, so this is also an assignment. Whatever is at right hand side, that will be assigned into the variable at left hand side. This is assignment. Okay, you can denote assignment by writing equal sign, or in the pseudocode you can denote assignment by writing this left arrow sign. Assignment always can be done from the right hand side into the variable at the left hand side. The other definition is sequence. Sequence. The steps of an algorithm are executed in the sequence from top to bottom, one after another. Suppose that I start from this point and I have various steps here. Step 1, step 2, I have n number of steps. Then after I stop. So the control will go from one step to other step. And when a control goes from one step to other step, this is called the sequence. Okay, means you are not selecting anything. Control is going from one step to another step by default. But here in this case, you are selecting something. You are selecting if value of I is less than 50, then you have to execute this box. Okay, you have to execute this statement. But if I is greater than 50, then you have to execute this statement. So here you are selecting what to execute based on the value of I. So this one is called selection. But the sequence is covering an algorithm step by step automatically. It's called sequence. Since an algorithm covers sequence of steps automatically, so this sequence must be in the right order. Otherwise, you end up getting a wrong result. So this was the sequence, and hopefully you got the meaning of selection also. Next definition is selection. This is a kind of selection. Means you are selecting which one to execute. If this is false, you have to execute something else. And if this is true, then you have to execute something else. This is the selection. And here in this flowchart, this is not only selection. This is iteration too. Okay. This is repetition also. Why this is repetition? You have to repeat this path until you get the value of I greater than 50. So you have to keep on repeating this path until the value of I is greater than 50. So this is the example of selection, because according to value of I, you can either go here or you can go here. But at the same time, this is the repetition, because until your value is less than equal to 50, you have to repeat this path. And I think we already have seen about the sequence, selection, iteration, and go to in the previous videos. So the other definition here is repetition or looping. Repetition or looping. When you repeat something until a condition satisfies, then this is called the repetition. So here in the flowchart, you can see we have repetition. Repetition is also called iteration. So repetition, looping, iteration are the names of same things. There are two kinds of looping, two kinds of iteration, two kinds of repetition are given in the Python. One is called for loop and other one is called while loop. But I am not going to discuss it right now. We will discuss them while learning Python programming. Now let's see few more examples of flowchart. The question is, draw the flowchart to add two numbers along with algorithm in simple English. Okay, you have to draw the flowchart to add two numbers along with algorithm in simple English. So you have to do two things. First, you have to write the algorithm in the simple English, and second thing, you have to draw the flowchart. So first, let's write the algorithm in simple English. Algorithm in simple English. Step 1. What to do in step 1? You have to start. What to do in step 2? Get two numbers n1 and n2. So n1 and n2 here are the variables. Here you are asking the user of the algorithm to enter two numbers of his choice. Okay, you are not assigning the values of n1 and n2 beforehand. You are saying the user who is using this algorithm to take number of your choice. That's why you have written get two numbers n1 and n2. So one number will be assigned in the variable n1 and other number given by the user of algorithm will be assigned in the variable n2. After that, the step 3. Step 3 is you calculate s n1 plus n2. Step 4 is print the result s. Okay, add these two numbers, store them in s. This is the assignment. I told you there are two ways to do assignment. Either you can write equal sign or you can write this arrow, left arrow. So whatever the summation of n1 and n2 is, that will be stored in the variable s, and then we are printing the value of the variable s. After that, step 5 is to stop. Of course, this is the algorithm in simple English to add two numbers. Now let's write flowchart for the same. Flowchart. Start, then read n1. Read n1 is the input. You are saying the user of algorithm to assign the value of n1. That's why this is the input given to the algorithm. That's why you need to draw a skewed rectangle. Read n1. After that, again you have to do read n2. This is the another input from the user. Read n2. The next one is the normal operation. So your rectangle should be normal, not skewed. So S is equal to N1 plus N2. You got the summation of N1 and N2 and the result of the summation is stored in S. After that you stop. Got it? This is the flowchart of adding two numbers. So hopefully you are getting what the flowchart is and what is the algorithm in simple English. Now let's see a very interesting question. To draw a flowchart to calculate 2 to the power 4, to calculate 2 to the power 4 along with the algorithm in simple English, along with the algorithm in simple English. Let's first do it in childish way. Childish way because this solution which I am just going to write is not a good way to solve this problem. Why I am saying it a childish way to solve this problem, I will explain it later. But let's solve it in a childish way. First, we have the algorithm in English. Step 1. Input, base and power. input, base, and power. Here the base is a variable. Power is also a variable. Okay. We assume that the input given by the user of this algorithm are 2 and 4. Okay. 2 has been assigned to the variable base, whereas 4 has been assigned to power. After that, we have a step 2. In the step 2, you have another variable called product that got assigned by the value of base. Whatever the value of base is, that will be stored in the variable product. Then you have a step 3. Step 3 is product multiplied by base. Okay, we have multiplied the base and product. Got it? Okay, maybe you are not getting it right now, but I will explain it. I will explain how it is working finally. So step 3 is this. After that, you have step 4. In the step 4, again you are calculating product is product multiplied by base. Then in step 5, again you are calculating product is product multiplied by base. Okay. So actually in these 4 steps, 2, 3, 4 and 5, you have multiplied 2 4 times. After it, in step 6, you print product. Then in the step 7, you stop. Now let's see how this algorithm is going to work. In the step 1, base is 2 and power is 4. What is the value of product? Tell me. The value of product is same as the value of base because you are assigning the value of base in the product. So this will be 2. Okay. Then you are calculating product. Product is equal to product multiplied by base. That means 2 multiplied by 2. That is 4. After the step 3, you have the step 4. In the step 4, again you are doing the same. Product is equal to product multiplied by base. Can you tell me what is the current value of product? The current value of product is 4. So 4 multiplied by base is still 2. Okay, 2. That means 8. Then we are at the step number 5. Product. What is the current value of product now? The current value of product is 8 now. So 8 multiplied by base, that is 2. That is 16. Okay. So we are done. We have calculated 2 to the power 4. Now step 6 is to print the value of product, print product, and this will print 16. Okay, this will print 16. After that you stop. So this is how your English based algorithm is working. Now let's draw the flowchart for it. The flowchart. Always start with a start, then input, input, base 2 power 4, base 2 power 4. Product is equal to base, then product is equal to product multiplied by base. Write it 3 times. Okay, we are doing the same thing, but we are doing it as the flowchart. So you did product is equal to product multiplied by base. Then you write print product. This is the output, so it should be the skewed rectangle. Print product and then stop. Got it? So first rectangle is skewed because this is the input. The last rectangle is skewed because this is the output. You have assigned base to the product. Then you are calculating product multiplied by base, storing that into the product 3 times. Now you notice here in this case, we do not have any selection. We do not have any iteration. We do not have any looping. We have just sequence. Okay. So sequence of boxes gets executed one after another. But there is a problem with this flowchart. Can you tell me what the problem is? For the power of 4, we have multiplied base to the product 3 times. Okay, first we stored base in the product, then we have multiplied base to the product 3 times. What if the power was 10,000? Will you multiply? Will you write this statement 9999 times? No, this is not that efficient. You should not write the statement 9999 times. So here we need something special so that doesn't matter what the value of power is, our algorithm should work fine. Okay, and of course I don't want to write this statement 9999 times if the value of power is 10,000. Okay, so this is the problem with this approach to calculate based on the power. Let's see a new approach. Let's first check the flowchart of new approach. You should start, of course, then again you should take input of base and power, input base 2 power 4. Then after you need to assign two variables, product and counter, to 1. Product is equal to counter is equal to 1. Okay? Each counter less than power, each counter is less than power. Tell me, each counter less than power is 1 less than 4. No. If this condition doesn't hold, then you should print product. Okay, print product. But if this condition holds, means counter is less than power, the idea is that you keep on multiplying product and base until the counter is less than power. Okay, means start from the 1, you multiply base and product, then counter will be 2, you again multiply base and product, then counter will be 3, you again multiply base and product, the counter will be 4. If the counter will be 4, then this condition will not hold true because you have to multiply it only for counter is less than power, not for equal to. So if this condition hold correct, then what you do? Tell me. Then you multiply product is equal to product and base. Product is equal to product multiplied by base, and then increase the value of counter. Increase the value of counter. Counter is equal to counter plus 1. Counter is equal to counter plus 1. Got it? And then just take this control and give it to this diamond box. Now let's start. You have to calculate 2 to the power 4. So what will you do? Your base is 2. Base is 2. Power is 4. Power is 4. Product is equal to 1 because of this statement. Product is equal to 1. Counter is equal to 1. Counter is equal to 1. Got it? Is counter less than power? 1 is less than 4? Yes, 1 is less than 4. You have to go at the yes direction. So what will be the new value of product? Product will be product multiplied by base. The older value of product was 1 multiplied by 2 is equal to 2. Okay, you did this statement. And you have to increase the value of counter by 1. So counter will be increased from 1 to 2. Got it? Now again you come here. Again check if 2, because new value of counter is 2, 2 is less than 4 or not. Yes, 2 is still less than 4. So again you calculate product is equal to product multiplied by base. What is the new value of product? That is 2. 2 multiplied by 2 is equal to 4. Increase the value of counter. So new value of counter will be 3. Is 3 less than 4? Is 3 less than 4? Yes, 3 is also less than 4. So multiply product and base. Okay. So multiply again product and base. What is the previous value of product? That is 4. Multiply it by 2 and you get 8. Increase the value of counter by 4. I think here is little bit problem because you need to go up to power. So counter should be less than or equal to power. Okay, just writing less than is wrong. So you should write here less than equal to power. Now, if this is less than equal to condition and the current value of counter is 4, then this condition will again pass and you are going to multiply 2 in the current value of product again to get 16. Now the new value of counter is going to be 5. 5 is not less than power. 5 is not less than 4. Therefore, the no condition occurs and you print the product. You print the current value of product, that is 16. Here you print 16. So it does not matter what the value of power is. This algorithm cover everything. Okay, if you put here 10,000, this loop will execute for 10,000 times. That's it. Okay, and you do not have to write it 10,000 times by your hand. This is the good thing about this approach. Now let's write the same code in English-like algorithm. Step 1, input base by the value of 2 and power by the value of 4. Then assign product is equal to, create two new variables actually. Product is equal to counter is equal to 1. Got it? Now use a while loop. While counter is less than power, counter is less than equal to power. While means keep on repeating the things until counter is greater than power. Okay. So while counter is less than power, then you have to calculate product is equal to, I'm writing here 3.1. Okay, because these steps will be repeated. Product is equal to product multiplied by base, and 3.2 is counter is equal to counter plus 1. So product is 1 initially. For the first time when counter was 1, you do 1 into 2. When counter is 2, you do 2 into 2. When counter is 3, you do 2 into 2 into 2. When the counter is 4, you do 2 into 2 into 2 into 2. When counter is 5, then this condition will not satisfy and 3.1 and 3.2 will not be executed. Let's go to the step number 4. At the step number 4, that means when the condition is not satisfied, then only you are moving to the step number 4. Otherwise, you keep on revolving, you keep on looping in these two statements. So at the step number 4, you print product and then stop. So this is the English-like algorithm for the same problem. So hopefully you got the points. I recommend you to go through all the solved examples of flowcharts. And if you have any doubt, comment me down, message me. I will answer it as soon as possible. The other topic we are going to start is pseudocode. What is the pseudocode? Pseudocode is an informal language. Okay. Pseudocode is an informal way to describing the steps of a problem's solution without using any strict programming language syntax. Without using any strict programming language syntax or underlying technology considerations or underlying technology considerations. That means, suppose that I want to write a code, but I am not very sure about syntax of any programming language. Therefore, by not following any strict rules of any programming language. I write a piece of code informally, and that is called the pseudocode. Getting it? For example, if a student's marks is greater than or equal to 50, if a student's marks is greater than or equal to 50, then display passed. Okay, otherwise that means else, display failed. This piece of pseudocode is not going to execute in any programming language. Right now I am not sure about any programming language, that's why I have written something informally. Okay, this is called the pseudocode. What are the advantages of pseudocode? Tell me. There are many advantages of pseudocode. Advantages of pseudocode. The first one is it uses language similar to everyday English, thus it is easy to understand. Okay? Pseudocode is just like English like language. It highlights the sentence of instructions. The structure of an algorithm is clearly visible through pseudocode. Means if I give you a C code, then it will hard for you to read that code and understand. If I give you a Python code, the same thing will happen. It will be hard for you to read that code and understand. But if I give you a pseudocode, it will be very easy for you to understand the procedure, that how it is going to be executed on the computer. Pseudocode can be easily modified without worrying about any dependencies, because I have just written informally. Pseudocodes are meant for written informally. The pseudocode is not meant to be executed by the system. Okay, you can change anything here. If I give you a Python code, you will be scared of changing on it. But if I give you a pseudocode, you will not be scared of changing on it, because that is not a running code. Okay, people are scared of changing the running code. They do not want to change a running code and stop that code working. But pseudocode itself is not working. You can change it. You can do the experiments on it. There are few disadvantages of pseudocode. Pseudocode is not that much visible as the flowcharts are. Okay, there is no accepted standard for the pseudocode. Therefore, it varies from person to person. Okay, this is another disadvantage of the pseudocode. Okay, the first disadvantage of the pseudocode is it is not that visual like flowchart. The second disadvantage of the pseudocode is there is no accepted standard for the pseudocode. It depends on who is writing it. Okay, everyone has their different ways to write the pseudocode. It can only be tested on the paper, means you cannot execute the pseudocode. Okay, it is not meant to be executed. It can only tested on the paper. Okay, it is an informal representation of the algorithm, or you can say that it is an informal code which is not meant to be executed on the system. So these are the few advantages and disadvantages of the pseudocode. So whatever we have written by using English steps to calculate the value of 2 to the power 4, all those English steps are called pseudocodes. Okay, those English steps are called pseudocodes. So hopefully you got the meaning of pseudocodes. And I recommend you to go through all the solved examples and see the various pseudocodes you have. And if you have any doubt, then please comment down. Now the question is, you have created an algorithm, but how you can be sure that your algorithm is correct? Okay, how you can verify an algorithm? Let's see the next topic, verifying an algorithm. Verifying an algorithm. How you verify an algorithm? Okay, the first method of verifying an algorithm is called dry run. Dry run. The dry run is a process of a programmer manually working through their code to trace the value of variables. If you remember, we have taken few values while calculating 2 to the power 4. We have taken few values and we have written step by ourselves. We have executed step by using pen and paper, and then we got the output as 16. While doing it, we found that there was an error. We had to do counter less than equal to power, and we were doing counter is less than power while checking the condition. So we correct that error, and after correcting that error, we again continued executing the steps on pen and paper. This act is called dry run, which we just did. A dry run is the process of a programmer manually working through their code to trace the value of variables. There is no software involved in this process. Okay, we have not executed our algorithm anywhere. We just have gone through it, just used our pen and paper to calculate the value of variables at various steps, and finally we found our output. That is the dry run. There are few characteristics of the dry run. The first characteristic of the dry run is it is carried out during design, implementation, testing, and maintenance. Okay, whenever you create an algorithm, you do the dry run to test if you are writing it perfectly or not. It is used to identify the logical errors in a code. Suppose that you are executing the code and you are not getting the output as your expectation. So you do a dry run. You take your pen and copy and you just write the steps by yourself and execute it manually on the pen and paper as we did. This is how you can catch some error, some logical error in your code. Then the third characteristic of the dry run is it cannot find the execution error in the code. Okay, means if there is an execution error, suppose that if writing in a statement is not valid for a given programming language, then your dry run cannot find such error. Of course, such error can be found only if you execute that code. So you cannot find the execution error in a code. So these are the three characteristics of a dry run. Hopefully you got it. And we did the dry run few minutes before. Other one is called trace table. Trace tables are also used to verify algorithm. What you do in the trace table is, suppose that you have an algorithm. This is the example algorithm I have. I am using it to explain the trace table. For number is means the values of this variable number will be 1, 2 and 3. Means starting from 1 up to 3. What you have to do, if the value of number is from 1 to 3, you have to calculate a variable val which will store number multiplied by 2. Then you print val plus 1. Got it? You print val plus 1. Now let's write the trace table of this. Here I am going to write the trace table for this. This is the line number. This is the variable number. This is the variable val, which is number multiplied by 2. And this is the printing of val plus 1. So what is the line number? Line number 1. The earlier value of number is 1. Okay, because number is starting from 1. What is the value of val now? Val will be number multiplied by 2. So 1 multiplied by 2, that means 2. In the line number 2, the val is 2. In the line number 3, you have printed val plus 1. That means you have printed 3. After doing it, you are done with the first iteration of the loop. Okay, the number is 1. In the next loop, this was the first loop. Okay, first loop, and this is the next loop, second loop. You have the 3 line numbers again, 1, 2, 3. The number you have is 2. You have increased the number. Okay, because the next number here is 2 in the line number 1. We have used 1 and then we have 2 now. What will the value of val now? Val is going to be number multiplied by 2. What is number right now? Number is right now is The number right now is 2. So 2 multiplied by 2 is equal to 4. And what you are going to print? You are going to print val plus 1. That means you are going to print 5. Now you have the third iteration. So this is how you keep on tracing the various values of various variables by using a trace table. Okay, line number 1, 2, and 3. In the line number 1, you again assigned the next value of number to this number variable, that is 3. The val is number multiplied by 2, that is 6, and you have to print here 7. So in every loop, now you are tracing the various values of all the variables. This is how you can verify the algorithm. Okay, this is another way to verify the algorithm called trace tables. So these are the two ways to verifying the algorithms. Okay, the first one is called the dry run, which we already did, and this is the trace table, in which you draw a table, you maintain the various loops, you maintain the various line numbers in the various loops, and then you find what are the values of different variables in different line numbers. So hopefully you are getting my points that how to verify algorithm. Now the last topic of this video is to compare two algorithms. Comparing algorithms. You can compare two things on the basis of its characteristics. So what characteristics an algorithm has? You can compare two algorithms on the basis of time taken by the algorithm. Okay? And you can compare two algorithms on the basis of space taken by the algorithms. On the basis of space taken by the algorithms. On the basis of time taken by the algorithms and on the basis of space taken by the algorithms. Space means memory space. Okay, how much MB it is taking for execution, how much time it is taking for execution. Okay, so this one is called time-based efficiency. Means how much time the algorithm takes to complete. This is called time-wise efficiency. Time-wise efficiency. And this is called space-wise efficiency. Space-wise efficiency. Space-wise efficiency means how much amount of memory, how much RAM size the algorithm takes to execute. That is called space-wise efficiency. A good algorithm takes less amount of time and less amount of space to execute. So by now, hopefully you understood what the problem solving is. What is an algorithm? What is flowchart? What is pseudocode? Hopefully you got all these points. In the next video, we are going to install Python in Windows and Linux. See you in the next video.